welcome to today's deep dive. We have got a really exciting mission for you today.
Yeah, we are exploring this comprehensive source that is just fascinating.
Right. It maps out a literal 23 project roadmap to achieving what it calls God-tier machine learning mastery.
Which is a wild title, but it really fits.
It really does. So whether you are actively studying tech or you're just intensely curious about how the AI tools you use every day are built behind the scenes.
This deep dive is going to totally demystify the black box of machine learning for you.
Exactly. We are tracking the exact journey engineers take to transform from basic data crunchers into true architects of autonomous AI.
It's an incredibly rigorous progression. And the core insight here is that we aren't just talking about learning how to use existing tools.
Like just importing an OpenAI library and calling it a day.
Right. This roadmap is about making a fundamental shift from knowing how a model works to mastering why it works,
Right.
and more importantly, why it fails.
Okay, let's unpack this, because looking at the early stages of this roadmap, the focus really surprised me.
Yeah, it's not about taking shortcuts.
No, it's about building these algorithms entirely from scratch.
What's fascinating here is the absolute necessity of first principles. To reach that top tier, practitioners actually have to do the raw calculus.
Calculus?
Yeah. For instance, there's a major milestone where they manually code the backpropagation for a neural network.
Okay, for those of us who haven't done calculus in a while, what exactly is backpropagation?
Fair question. It is basically the mathematical feedback loop that tells the AI, hey, you got this wrong. Adjust your internal weights and try again.
So by physically writing out that math, the engineer deeply understands exactly how a system learns.
100%.
Mm.
If you skip this step and just rely on prepackaged tools, you become a very fragile developer.
You simply won't know how to troubleshoot complex deep learning architectures later on.
Exactly. You hit a wall.
That makes total sense. Now, before they even get to neural networks, I saw the Titanic dataset mentioned as an early project.
Oh yeah, the classic Titanic project.
How exactly does a 100-year-old shipwreck teach someone about modern AI?
It's actually a brilliant exercise in what we call feature engineering. You aren't just feeding raw passenger data into a machine.
You have to craft relevant features to boost the predictive signal, right?
Yes. So you might write code to pull social titles, like Mr. or Countess, out of the raw passenger names.
To find hidden survival signals based on class or gender.
Precisely. You are finding the hidden patterns.
Oh, that's clever. So if the Titanic data is the training wheels, what happens when they finally take them off?
The complexity escalates significantly, especially in time series projects like stock price forecasting.
Right, where traditional testing methods completely fall apart.
Because when you are dealing with financial markets, you have to use walk-forward validation to avoid what is called look-ahead bias.
Wait, so you're saying if I just randomly shuffle my stock data, I might accidentally let the AI cheat?
Yes, by giving it next week's numbers to predict tomorrow's price.
So I'd be building a time machine, not a predictive model.
Exactly. Walk-forward validation forces the model to only use past data to predict the future, which matches reality.
Here's where it gets really interesting. Once you master those foundations, you hit phase 3.
Which tackles advanced architectures.
Yes. The roadmap highlights building a language model entirely from scratch. You even get to fine-tune a custom Rick Sanchez chatbot.
Which is amazing.
Though giving an AI that level of existential dread seems a little risky.
It's a fun project, but the underlying lesson is vital. You aren't just tweaking an existing AI, you are implementing the actual transformer architecture.
You build the attention mechanism.
Which, simply put, is the system that teaches the AI which words in a sentence matter most. Just like how humans pay attention to context.
Which is huge for you listening. If you've ever wondered why your ChatGPT prompts sometimes go completely off the rails, this phase 3 project is exactly where engineers figure out how to fix that.
And that sets up the ultimate evolution.
Where does this all culminate?
If we connect this to the bigger picture, data scientists stop just tuning individual models. Instead, they start building robot data scientists.
Like custom automated ML tools.
Yes, they engineer autonomous ML agents capable of choosing their own problems and gathering their own data.
The practitioner becomes an architect of intelligence.
Exactly. They aren't just mechanics anymore.
So the ultimate goal of an engineer is to build a program that does their programming for them so they can just take a nap.
Basically, yes. That is the dream.
So what does this all mean for you, the listener?
It proves that AI isn't magic. When you look at this 23-step journey, you realize artificial intelligence is just a ladder.
It is an incredibly complex, interconnected system built on mathematics, software engineering, and business logic.
And each rung builds logically on the one before it.
It is incredible to see the full path laid out like that.
Okay.
But I want to leave you with one final thought to mull over today.
It's a big one.
If the absolute pinnacle of this roadmap, the God tier level, is engineering an autonomous AI agent that can independently choose its own problems.
And gather its own data and build its own models.
Right. At what point does the human architect successfully engineer themselves out of a job entirely?